everyone, my name is Rafa. Today I will solve the calculus 2 YouTube assignment. I have the function and I have the constraint, and I have to use Lagrange multipliers to find maximum and minimum values of it. So let's start. So first thing that we need to know about Lagrange multipliers, of course it's formula. The gradient of the function is equal to lambda multiplied by the gradient of our constraint. And we're gonna work with that formula. So, first thing that we have to do is to find for each component of both equations. So first we're gonna find for the x. In this case, we have to find the derivative of x with respect to x, which is 4x cubed equal to lambda multiplied by the derivative of x in the constraint, which is 2x. From here we get that 2x squared equal to lambda, and that's all. Now we're gonna do the same for the y component. Again, same thing, the derivative of y in our function, which is 4y cubed equal to lambda multiplied by the derivative of y component in our constraint, which is 2y. Now we have the same answer, and we're gonna do the same for the z component. Again, 4z cubed equal to lambda multiplied by 2z. And now z squared is equal to lambda. So, as you see, we found all the lambdas, and we can say that 2x squared is equal to 2y squared and equal to 2z squared, because all of it is equal to lambda. As you see from our constraint, we don't have any coefficients before the component, so I suggest you to multiply all of it by 2, which will be x squared is equal to y squared equal to z squared and equal to lambda over 2. So as we have these values, we can plug it in our constraint and find the value of lambda. So now that we have the values of x squared, y squared, and z squared, we can replace it in our constraint and just write that lambda over 2 plus lambda over 2, once again lambda over 2 is equal to 1. This is 3 over 2 lambdas equal to 1, and from here we can say that our lambda is equal to 2 over 3. Now that we have our lambda, we can also find our x, y, and z from this. So, as you see here, for example, just going to take x, 2x squared is equal to 2 over 3. X squared, 2 over 3, multiplied by 1 over 2. X squared is equal to 1 over 3, and x is square root plus minus 1 over 3, which is also true for y and z because they all equal to each other. So now that we found the minimum value of our function, which is 1 over 3, we have to find the maximum value of our function. And we have two cases for that. First is when one of the components x, y, z is equal to 0, and second one is when two of the components is equal to 0. And as we don't have that much time, I will just talk about the one that gives us the maximum value of our function, which is when we have, for example, x and y equal to 0. So as two of our components are equal to 0, we plug it in our constraint, which is 0 square plus 0 square plus z square equation, we can find that z is plus or minus 1. Now we can plug it in our function. X to the fourth is y to the fourth plus z to the fourth, which will be 0 to the fourth, 0 to the fourth plus minus 1 to the fourth, because as we have the even degree, it doesn't matter. Our answer will still be 1. So by using Lagrange multipliers, we found the minimum and the maximum value of our function. Thank you for your attention. So now the derivative of y with respect to y, constraint, which is 2y.